All right, here we are in our green book again. Human Body Systems, Chapter 1. We're going to look at Section 2, the muscular system. You will knock this out over the 4-day weekend so that we can come back on Monday and have a journal quiz on Sections 1 and Section 2. You can do this all at once, or you can take 2 days to do it. It's up to you. We have Section 2, the muscular system. We're on page... what page is it? I don't know. You'll find out. You find it. Muscular system. Okay, what we'll learn. We're going to identify the major function of the muscular system. I think you know that. Common sense. We're going to compare and contrast. There's 3 different types of muscles. So we're going to learn about those and how muscle action results in the movement of body parts. Okay. We've got a good little bit of vocabulary, which we're going to put into our notes. And here we go. All right, movement of the human body. The golfer named Christopher looks down the fairway and then at the golf ball. With intense concentration and muscle coordination, Parker swings the club along a graceful arc and connects with the ball. The ball sails through the air, landing inches away from the flag. The crowd applauds Christopher. A few minutes later, Parker makes the final putt and wins the tournament. Woo! The champion has learned how to use controlled muscle movement to bring success. Muscles help make all of your daily movements possible. Figure 6 shows which muscles connect some of the bones to your body. A muscle is an organ that can relax, contract, and provide the force to move your body parts. In the process, energy is used and work is done. Imagine how much energy the more than 600 muscles in your body use each day. No matter how still you might try to be, some muscles in your body are always moving. You're breathing, your heart is beating, and your digestive system is working. Okay, those are all operated by muscles. All right, our muscles come in many shapes and sizes. Even simple movements require coordinated use of several muscles. The muscles shown here are only those located directly under the skin. Beneath these muscles are middle and deep layers of muscles. So if you go get a massage, you might get a deep tissue massage. Okay, that massages the muscles underneath the surface muscles. All right, the muscular system, Roman numeral. Oh boy, that should be Roman numeral 2. So sorry. All right. A, movement of the human body. Okay, we have our definition. A muscle is an organ that can relax, contract, and provide force to move body parts. All right, B, we have over 600 muscles. They use energy and do work. Okay, my question to you is, where does the energy come from? Okay, you need to answer that on Monday. Where does the energy come from? All right. Muscle control. Your hand, arm, and leg muscles are voluntary. So are the muscles in your face, shown in Figure 7. You can choose to move them or not move them. Muscles that you are able to control are called voluntary muscles. In contrast, involuntary muscles are muscles you can't control consciously. They go on working all day long, all your life. Blood gets pumped through blood vessels, and food is moved through your digestive system by the action of involuntary muscles. Okay? So you're going to answer this reading check on Monday. What is a body activity that is controlled by involuntary muscles? All right, we're going to have a number 1 here, muscle control. We have 2 definitions in there. So think ahead. What are the 2 definitions? What are we going to write? Voluntary muscles, you are able to control, and involuntary muscles, you do not control consciously. Pay attention to this word consciously. It means you don't think about it. You don't have to think about breathing, your heartbeat, digesting your food. You do have to think about moving your hand, writing, any physical activity that you do. Okay, we have to understand what consciously means. All right. your body's simple machines, levers. Okay, this is not going to be new to you because this is how we started this unit. Your skeletal system and muscular system work together when you move, in the same way the parts of a bicycle work together when it moves. A machine, such as a bicycle, is any device that makes work easier. A simple machine does work with only one movement, like a hammer. The hammer is a type of simple machine called a lever, which is a rod or plank that pivots and turns about a point. This point is called a fulcrum. The action of muscles, bones, and joints working together is like a lever. In your body, bones are rods, joints are fulcrums, and contraction and relaxation of muscles provides the force to move the body parts. Levers are classified into three types: first class, second class, third class. We know this. Examples of the three types of levers are found in the human body are shown in figure 8. Okay, so the joints act between the bones as the fulcrum. Your body's simple machine, levers. Okay, the bones are the rods, or we had it written down as a rigid bar, if you remember. Joints are the fulcrum. And we're going to go to the next page because I have the classifications. Okay. Right here. All right, so this is a picture here of the three different classes of levers. We talked a lot about the third class levers, that the input force is between the fulcrum and the output force. So all of our elbows, knees, fingers, toes, not toes, well, our third class levers. The second class lever is the ball of our foot. So when you raise up on your toes, that's a second class lever because the weight of your leg is between the fulcrum and the force, your calf muscle pulling up. Now we did not discuss the first class lever, which is the pivot joint in your neck. Okay, so let's write these down. The first class lever is a pivot joint in your neck. Second class lever is the ball of your foot. And third class lever would be your elbows and knees. Okay, I'm kind of going fast because we did this already. All right. Now, classification of muscle tissue. Okay, remember that we said we have voluntary muscles, and that is those are called our skeletal muscles. Then we have two other types of muscle tissue. So, classification of muscle tissue. All the muscle tissue in your body is not the same. The three types of muscles are skeletal, smooth, and cardiac. The muscles that move bones are skeletal muscles. They are more common than the other muscle types and are attached to bones by thick bands of tissue called tendons. When viewed under a microscope, skeletal muscles are striated and appear striped. You can see the striations in figure 9a. Skeletal muscles are voluntary muscles. You can choose when to walk or when not to walk. Skeletal muscles tend to contract quickly and tire more easily than involuntary muscles do. The remaining two types of muscles are shown in figures 9b and 9c. Cardiac muscle is found only in the heart. Like skeletal muscle, cardiac muscle is striated. This type of muscle contracts about 70 times per minute every day of your life. Smooth muscles are found in your intestines, bladder, blood vessels, and other internal organs. They are non-striated, involuntary muscles that slowly contract and relax. Internal organs are made of one or more layers of smooth muscle. Okay, so what if that is new to you? Classification of muscles. We have skeletal muscle. All right, skeletal muscle moves bones, the most numerous, attached to the bone with tendons, is striated, is voluntary, reacts quickly, but tires very easily, relatively speaking. Cardiac muscle. It's found only in the heart, is striated, It's involuntary. It does not tire easily, thank goodness. Okay? And finally, we have smooth muscle, found in the intestines, bladder, and blood vessels and other organs. It's not striated, not striped. It's involuntary. And smooth muscle is in between. It does react. It reacts, but doesn't tire easily. All right, working muscles. We're going to do this all at once, aren't we? Let me see. Okay, so we only have 2 pages left. I think we'll keep going. All right, working muscles. How do muscles allow you to move your body? You move because pairs of skeletal muscles work together. When one muscle of a pair contracts, the other muscle relaxes or returns to its original length, as shown in Figure 10. Muscles always pull. They never push. When the muscles on the back of your upper leg contract, they shorten and pull your lower leg back and up. When you straighten your leg, the back muscles lengthen and relax, and the muscles on the front of your upper leg contract. Compare how the muscles of your legs work with how the muscles of your arms work. Okay, so it's very important to realize that when you move, it's one muscle contracting while the other muscle relaxes. Okay, working muscles. Muscles move in pairs. When one contracts or pulls, the other relaxes. Easy sneezy, huh? All right. Okay, changes in muscles. Over a period of time, muscles can become larger or smaller, depending on whether or not they are used. Skeletal muscles that do a lot of work, such as those in your writing hand, become strong and large. For example, many soccer and basketball players have noticeably larger, defined leg muscles. Muscles that are given regular exercise respond quickly to stimuli. Some of this change in muscle size is because of an increase in the number of muscle cells. However, most of this change in muscle size is because the individual cells become larger. In contrast, if you participate only in non-active pastimes, such as watching television or playing computer games, your muscles will become soft and flabby and will lack strength. Muscles that aren't exercised become smaller in size. When someone is paralyzed, his or her muscles become smaller due to lack of use. Okay, so it's terribly important you all get exercise and keep your muscles strong. Changes in muscles. Number 1. Individual cells become larger. Oh boy. All right. Sitting can cause flabby, weak muscles. What have I done? Okay, and I'm missing one here, aren't I? So changes in muscles. Let's see. Let me move this up. Individual cells become larger. Sitting can cause flabby, weak muscles. And then we have to have a C that not only can the individual cells become larger, but sometimes, what did it say? Some of this change in muscle size is because of an increase in the number of cells. So sometimes, how should I say that? There are more muscle in the CLE cells. Okay. So we're going to go to the last one. How muscles move. Uh-oh. Am I recording? All right. Your muscles need energy to contract and relax. Your blood carries energy-rich molecules to your muscle cells where the chemical energy stored in these molecules is released. As the muscle contracts, this released energy changes to mechanical energy, movement, and thermal energy, warmth. as shown in Figure 11. When the supply of energy-rich molecules in a muscle is used up, the muscle becomes tired and needs to rest. During this resting period, your blood supplies more energy-rich molecules to your muscle cells. The thermal energy of muscle contractions helps keep your body temperature constant. Okay, so when Coach tells you to warm up, he's wanting you to get your muscles moving so they create the thermal energy. You're really warming up your muscles. Okay, how muscles move. Number 2. Blood carries energy-rich molecules to the muscle cells. Okay, where does this come from, this energy-rich molecules? Chemical energy is released to the muscle. The muscle contracts and converts chemical to mechanical and thermal. All right, movement and warmth. All right, that's it. That's good because third period's about here. Yay, I hope you all have a great break, and I'll see you